So there are a couple people that are also on this project, Dr. Kim Childs and Debbie Pace, who aren't here today. But there's a need for K through 12 teacher leaders, and these are teachers within each school or each district. And the reason we need them is it will improve instruction, and research has shown this, and they can provide quality in-house staff development. Instant accessibility. Right now, Texas, if you want professional development, there are 20, I believe, educational resource centers, and they can be as far as 100 miles away from a rural school district where you would have to send your teachers for a day of professional development. Enhanced credibility, since they're still practitioners. They can provide specific strategies towards districts, and some vertical articulation across grade levels. So we wrote 2 NSF grants to do multi-year programs. One was the Texas Leadership Grant, and that was an extension of an MSP grant, and the other was the Texas Leadership Initiative, or the Texas Limit. And these are just, the last one's finally winding down. And the goals of these programs was to take highly qualified teachers, so all of these teachers, they're middle school qualified or secondary school qualified, although some of them are still in the elementary schools, and develop them into teacher leaders. In other words, train them to give professional development and provide differentiated instruction and you know, to effectively improve the school system. So the structure of the programs, both of them are structured very similarly. They were multi-year programs. I think one was 3 and one was 5, although NSF told us to wrap it up in 4. Typically they met 1 weekend a month, 1 Saturday a month, and 2 3-day summer workshops. So for the activities in these programs, it wasn't just learning mathematics, but there was some new mathematics, and specifically we concentrated on geometry, probability, and algebra and functions. And we also wanted to develop them into a professional learning community, so when they left, okay, they would communicate, and so they were coming to East Texas from as far away as Irving in the Dallas-Fort Worth area, and Victoria, which is way on the other side of Houston from us. We wanted them to become consumers of mathematics education research, so they should be able to read what's going on as far as that goes and understand it. We didn't expect them to produce math research. We wanted them to be able to understand how professional development is delivered and to create some modules. So how does IBL fit into this? Okay, so from the AIBL website, I stole these 2 quotes, and one says there's a deep engagement in rich mathematical activities, and there must be an opportunity to collaborate with peers. So I'm going to give a working definition of what we considered inquiry-based learning and why we considered it. So an inquiry-based learning classroom is a community where students engage in rich mathematical activities and assume responsibility for their own learning. And we needed a broader definition because teaching a more method topology course or introduction to proof course, even though they were doing new mathematics, really wasn't going to fit with this group. Okay, the format just was not set up for it. Okay, but we felt that inquiry-based learning was important. So why do we want to do IBL for teacher leaders? Well, there's a lot of research out there that shows that if you do professional development, and I suspect the same thing happens with our own students, and you just do them new topics or changing a limited number of teaching practices, what they're going to do is they're going to take everything and fit it into what they know and discard the rest, okay? And what we really wanted was a transformation. Transformative learning, okay, requires a complete change, okay? We wanted it to change in existing beliefs and practices and we wanted them to realize that there might be a better way of doing things. Okay, and one of the big difficulties for this group was they would always come in and will say, well, my students can do this and that my students can't do this, or this would work with my students. And we would tell them, well, that's true, but your new clients now are your colleagues, not your students. Okay? And we thought that IBL experiences might be an effective tool to develop this transition from teacher to teacher leader. So there's this theory of cognitive dissonance that is around in educational psychology, and it was developed in 1957. And it says that before you can move on and go to a new body of knowledge, that you've got to feel some discomfort, okay? Otherwise, you're going to fit it into what you know and try and categorize it. So you want to be presented with conflicting ideas and be able to resolve these situations. In order to create such situations, it's been proposed that activities can help create and resolve dissonance in teaching situations and practices, and we thought that IBL was a perfect vehicle for this. So, and then the final thing you have to do, this isn't going to work in a one-day or a 2-day workshop. Okay, it's got to be continuous because they've got to have time to work through this and actually change their beliefs and practices. What about examples of IBL for teacher leaders? So I'm going to give 3 examples. We can do new mathematics, okay, and one of the things we considered was, well, everybody knows what the conic sections are, the parabola, the hyperbola, the ellipse, circles, okay, but what if we ask them to do this in a different setting where we have the taxicab metric instead of the normal Euclidean metric? Another was, analyzing classroom video of an IBL class. And then finally, looking at case studies and actually having them lead case studies, okay, which is something that they can turn around and do very well. And we thought that that was a good way of doing inquiry-based learning experiences. So, an example of a taxicab metric, and this took a couple of Saturdays, okay, to work through it because it's much more complicated than you think. The usual method is the Euclidean method algorithm that is given below there, but the taxicab metric is a little bit different. And if you think about how a taxicab would drive in a city like New York City where the streets are laid out on a grid, they don't go from point A to point B. Rather, they go like this and can't cut across the middle of a block. So then we asked them, well, what does a circle look like under the taxicab metric? Well, it no longer looks like the circle that we're familiar with. Of course, it looks like a diamond. Okay, and pi is no longer 3.14. Does anybody know what it is? Actually, it turns out to be 4. Okay, the ratio of the circumference to the diameter. So, and then, what do the other conic sections look like? Okay, what is an ellipse? What is a parabola? What is a hyperbola look like? And this can get very complicated, okay, and it takes a while to resolve all the cases. So analyzing classroom video, we brought in an expert, Stan Yoshinobu, and he came to campus, and they're still talking about him several years later. And he showed a video, and it's actually several videos, and one is from this material that's used at UC Santa Barbara and the Young Mathematicians series. And this particular video was called Turkey Investigations, and it takes about 2 hours to work through. And it's a third grade classroom in Manhattan, and the students know how to add, but they don't really know how to multiply. And the first question one day, students were asked, okay, by the teacher, told them, I have to buy a 24-pound turkey. Turkey costs $1.25 per pound. How much money should I take to the grocery store with me? And they can't just do 24 times $1.25, and get $30. They actually worked through it, and they had some marvelous strategies, and the teacher you know, if you don't think IBL works in a third grade classroom, you need to see this video because she is just a master. And of course, the next day she comes back, says, I bought the turkey and now I have to cook it, okay, and it's 15 minutes a pound. How long do I have to cook it for? Well, there's a multiplication problem which they don't know how to do. It's 360 minutes, but it's also a division problem which they have to figure out. They figure out some more marvelous strategies there. And you can actually see these kids intuitively using and understanding what the distributive law is about. So for the third example, okay, we use case studies, and case studies, there's a whole book on Windows in Teaching Math by Kay Merseth, who's at the Harvard School of Education. And in particular, we used one called, introduced one called Lost in Translation, which I led, where Mrs. Harper was trying to make sense of an incident that happened in her low-performing algebra class, and things go into a mess, and you get this whole case, and then you start asking the teachers that you're working with, what do they do? Okay, or what do you think about this, what's going on? And there's a whole protocol for working through these case studies. There is an instructor's manual. And to lead the case study, basically what you do is, what you do with any IBL is, you never make a statement, you always ask a question, okay? And of course there are ways of nudging people from point A to point B by asking the right question. And then they each picked a case study and turned around and delivered it to the rest of the group, okay? So they had some practice, and they were actually able to go back to their schools the same month and actually had something they could quickly put into professional development. Okay, so are these programs working? Okay, so here are some quotes. We think they are, but here are some quotes from the teachers. I've never had an opportunity to just sit and work on developing the problems we were given the opportunity to work on, and I enjoyed being able to do so. The case studies and lesson studies were great opportunities for interaction with other teachers. The activities on geometry and rates of change helped me think more deeply about these concepts than I would in an ordinary classroom. The presentation by Dr. Yoshinobu really stimulated my interest in pursuing more inquiry-based learning opportunities for my students. After this presentation, I feel that this is how students learn best. The NSF programs completely changed my learning. First, the programs made me truly learn and build upon that learning. Second, I learned how to share my new knowledge with my peers, and in doing so, I've begun to build a solid professional learning community. And keeping in mind that we were trying to train them to become professional developments, we finally got it through that their clients are their teachers. So plan, 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 and more planning. Successful PD doesn't just happen, it's carefully designed. And the last one, I've just gained so much more confidence through this program. I can be an effective mentor because of this program. And I think I'll end right there, and if there are any questions.
Not a question, but just an observation and a comment that a number of the math-science partnerships, whether targeted on middle school or more comprehensive, I'm involved in one in Alabama, are getting some similar results and similar effective changes from both teachers and those that we're trying to develop as teacher leaders. The way this is going to work is if it actually comes from the teachers, and I'm very happy to see that there are probably at this meeting more secondary school teachers than there have been previously.
When will the project be completed? That's the first part of the question. And second, have you published anything regarding the results of this project?
The first project, the leadership project, finished in December. The limit project is just finishing now. They met for the last time last month. I've just collected the final data. We just submitted our first paper to the Journal of Teacher Education, I believe. I've got 2 more that are written. I'm trying to get my co-authors to put their stamp of approval on them. Well, 1.5 more, and then I've got another one planned.
I also want to follow up with a similar comment. We're doing something similar in California, and we found that this has been especially helpful with the implementation of Common Core standards and allowing these teacher leaders to bring things back to the classrooms and to other teachers in a similar fashion. So,
how are you collecting evidence that they're actually taking these ideas and using them with the teachers that they are leading in their school districts?
So we're collecting data in a couple different ways, and if I had thought about this right from the beginning of the program correctly and designed it a little bit better, we would have better data. So we've got surveys back from the teachers we've been working with, and for the teachers that they have been delivering professional development to, we did what's called a KAT, Knowledge for Algebra Teaching, which is done out of Michigan State, and a pre and post test with them, and the LMT for the middle school and elementary school teachers, and collecting data there, and they're also filling out a survey. And so that's the data I have to work with. And these quotes came from the survey that our teachers did, the PD teachers, the teacher leaders.
Okay, thank you.
We're probably running into time for our next speaker here, and it's hard for me to keep track of things and talk at the same time, so I think I'm going to finish here, and we'll get ready for the next speaker.